Welcome. Let's have a look at Day 6 Guard Gallivant Part 2 for Advent of Code 2024. For this second part, what they would like to know is how many positions can we place an obstacle so that the guard would be put into an infinite loop. So they decided to place an obstacle here where this capital O is, or 0. And notice if we move up, to the right, down, and then to the left, if this was an obstacle, we would be forced to move right, or which is up. So this would be an example of what they're looking for. And so it just so happens that for this part 2, for this example or exact test data they give us, there are 6 locations that would yield 6 locations for placing an obstacle that would put the guard in an infinite loop. One piece of information is that we're not allowed to, the new obstruction can't be placed at the guard's starting position. So we need to keep that in mind as we solve this part 2. So let's do that. So most of this is the same. I did modify it slightly, but let me just go over it. So as before, I did, this is all exactly the same as before. I looped through each of the rows of the file. I stripped the new line, add it to the graph. I look for the caret, and if I find it, if I don't find it, it throws an error, which is nothing to be worried about. Otherwise, I store it. This is the starting guard location. This is all the same as before. I did modify this part here where now I make an empty set, whereas before I placed the guard here, but it's fine to do it like this. Once you enter the loop, you would add the guard or any location that you're at. I check the bounds. If you're out of bounds, I break, which means we're out of the map, which is fine. If we encounter an obstacle, we change directions as before. So I update I, and then I modify 4 because we have only 4 elements. Otherwise, we continue moving in the same direction. So I just keep moving in the same direction. Then otherwise, we print the number of cells that we have visited, unique cells. We can just run that really quickly, maybe. So we get 41. So now let's move on to part 2. So for part 2, let's try a brute force approach. So for RR in range row, for CC in range call. Now we can only place an obstacle where there's a free cell. We cannot place an obstacle on an obstacle, or would it make sense? And an obstacle on the guard location. So if G of RR CC equals or not equal, then we discontinue. Otherwise, we run this loop here, perform the simulation here. And let's maybe fix the indentation. Now remember, we are running a simulation, so we're adding an obstacle there. So let's do that. RR. Let's add an obstacle there. Don't forget to put it back to how it was before. So let's put back the period. So after we run the simulation, let's put back the dot, how it was. Now, in order for us to run the simulation, we need to reinitialize things as we had them over here. So let's do that. So then the initial direction is I. For convenience, we said DRDC and set, a brand new set. One thing we're going to have struggle with is this here. So R and C, I've used them already. So let's store the source row and source column And so we can reuse them over and over again. We'll do this. So now this fixes this part. Brand new set. All this looks good. Let's use a new variable for storing the loops. And what we need to do is, if we go back over here, how do we know we've reached a loop? The way we know we reach a loop is if we're at the same cell going in the same direction as before. So yes, so again, the only way we know we're in a loop is if we're at the same cell that we visited before. However, we need to be going in that same direction that we've also been in. That indicates a cell, a loop. However, though, something like this, though, remember, if you go up to the right, down to the left. So in this case, notice that we have been here before, but it's not where the obstacle is. So we move to the left, up, to the right, down, then to the left. So only when we hit this spot on the third iteration do we know that we're in a loop. Remember, the first time we're here, because that's our starting location, that's not a loop. When we hit it again, we're actually just going past it. So we've hit this cell, but in a different direction. That's not enough for a loop. But then when we hit it the third time, we are in a loop because we're going in the same direction. That's the key indicator for that cell. So what we'll be storing here is also the direction and for the row and the column. And then what we'll do is we'll be checking every time we change the direction or the column or the row and column. We'll need to perform a check. So if RC DRDC in V, well, we can break. Also, don't forget to increment our loop. Loops plus equals 1. Not sure what's going on here. Okay. So let's print. We can just print it now that we're done. We can just print the loops count. Let's see what we get. Print loops. And let's see if that works. Fingers crossed. 0, did I? Row, column. Oh yes, sorry about that. We need to initialize here. Sorry about that. And then that should work. Okay, cool. Sorry about that. Now for the optimization. All right, so let's close this for now. So what I realized was that let's go over here. So remember the brute force approach says to place an obstacle. Now what I realized was if we place an obstacle here, that wouldn't affect our answer because we never traveled there in the first place. So my approach is we'll only check for obstacles if we visited that cell before. Otherwise, we don't need to check any of these here, any of these. Remember, we don't need to check anything that's not in our path that we have visited before. So that's fine. We can use that to our advantage. So that's it. That's the point. So my previous answer took about a minute to solve, and this one takes about 10 seconds. So a 6 times improvement. So we'll take it. So let's go back where we're at. So let's go back to this problem, and then we'll do. So if you'd like, I can just run it here and you can just see it. I'll probably stop it after a while. So data 6. We can run it, and you'll see how long it takes. So that's part 1. So now it's still running for part 2. So 5177 was my answer for part 1. Where is it at? Yeah, here. And so part 2 is still running. So it's going to take too long. So let's clear that and let's make the improvement. So we only want to travel on the cells that we visited before. So let's take off all this, and we'll do this here. We'll say for RRCC in V, and then we need to fix this indentation. I think this, and then we need to. What do we need to do? We need to adjust our set. So this is in V, so we'll make this V1 here. So for this first one, we'll call this V1, V1. And I think that's it. So these are all the cells that have been on our path. We run the simulation again, and I think that's it. Okay, let's run it. This may, oh, sorry, 78, 38. Okay, yes, sorry, this would be V1. Not a big deal. So this is the first answer. Now the second answer should be done in about, we'll say 4 more seconds. 1, 2, 3, 4, 5, 6, 7. Well, there you go. We'll take it. And there it is. So that wasn't too bad. 1686. That was the answer I got here. So cool. If you have any questions, or if this was enjoyable, or if you learned anything and found it valuable, please like or subscribe. Other than that, have a wonderful day. Take care.